Hey, what's up everyone? Welcome back to Next Gen Byte. Today we'll be looking at a very important topic called sliding windows. So without further ado, let's get to it. So let's start off with what basically is a sliding window. So a sliding window is basically like you have a certain array, let's name it A, of size n, and you select a specific point, and then you drag this whole thing towards the end of a list. So like basically you just kind of drag this whole thing. Now you might be asking, hey, then if this is sliding window, then what is the difference between a sliding window and a two-pointer approach? So let me tell you what is basically the major difference. So let's reconstruct our array and create two pointers. Okay. So as you know, two pointers always point towards two distinct points. It can be same, but each pointer only points towards one specific value. The main difference between two pointers and sliding window is that in sliding window, we store the data between these two pointers. And whereas in only a two-pointer approach, there's no need to store it. So yeah, now since we know the fundamentals of our sliding window approach, let's look at its types. So mainly there are only two kinds of sliding window approaches. First one is our fixed sliding window, and the second one is dynamic sliding window. So let's start off with fixed sliding windows. So what are basically a fixed sliding window? So let me just reconstruct the array. You have an array A and you select a certain part and you slide it across. Right. Now the thing with fixed sliding window is that this specific selected area will remain fixed. Yeah, that is basically it. No matter where you move it, it will always be fixed. You cannot like expand this part, retract this part. You cannot do anything like this. You can just move it from left to right. And that's just basically it. That is called a fixed sliding window approach. Now, before looking at our dynamic sliding window, let's first look at an example. All right. So here, as you can see, we got lead code problem 643, maximum average subarray 1. So you are given an integer in nums, and it consists of n elements, and you're also given an integer k. So your task is to find a contiguous subarray whose length is equivalent to k and has the maximum average value. So basically what they are asking is that you're given an array of size n and you need to find a subarray. Subarray is just basically a part of adjacent elements. So like, let me give you an example. If you have like A, B, C, D, so A and B is our subarray since they are next to each other. And a subarray can also be empty. So what they are asking is that you have to find the maximum average of all the subarrays. So let's say you have an array 1, 0, 5, 4, and you are given k is equal to 2. So you can first check this subarray 1, 0, Then you can check this subarray 0 and 5. Then you can check this subarray 5 and 4 and find out what's the maximum average, and then that will be your answer. In this case, it will be 5 plus 4, which is equal to 9, divided by 2, which is equal to 3.5. So this is basically what our question is. And this is an example of a fixed sliding window approach, since we are already given a fixed window of size k. And if we look at the constraints, we can see that k and n is always greater than 1. So good news, we don't have to account towards empty subarrays. Now let's see how we can approach this problem. So basically, we know that our output is the maximum of window 1 divided by k. Since that is the number of elements in that specific window, then we can just w2 divided by k again, and so on till wn. And yeah, this means till our nth window. Now you can see that our k here is always constant. And since it's always constant, we can rewrite this equation as output is equal to the maximum of w1, w2 till wn whole divided by k. So yeah, basically what we have to do is find the maximum subarray sum of the whole array. So we just need to select a part of the array that has the maximum possible sum. And that should be our output if we plug that in this equation. So how do we approach this problem? How do we calculate the maximum possible sum of a specific subarray of size k? Gosh, that's long. So let me give you an example. I'm going to take this example. Thank you, lead code, and let me just paste it. So you're given 112, -5, -650, and 3, and the size of our window is 4. So what we can basically do is initially construct a variable current, which will store the sum of the first 4 elements. And the sum of the first 4 elements is 1, 13, 13 minus 5, 5, which is equivalent to 8, 8 minus 6, which is equal to 2. So our current is equal to 2. Then we can just move our window forward. And to move it forward, we can just add this item and subtract this item. This would increase or decrease our current variable, and we can also create another variable ms, which will store maximum of the all current windows available. Since you can just write maximum of A, B, and C as the maximum of A and maximum of BC. That's just a general rule. You can just keep on like recording the current maximum using this ms variable. So now we understood the basic analogy on how to approach this problem. Let's try to code the solution. So let's code our solution. So here we are given nums and k. I usually like to record the size of array in a variable because it's easy to use. So I can just do int n is equal to nums.size. This keeps it very simple. So anyways, we can create our variable current. Initially set it to 0. Then for each item till size k, I is equal to 0. So you can just do current plus equals nums I. Then we can also make our ms variable, which will store the maximum window yet discovered. Initially, we can just set it to our current window because, if n is equal to k, then we always have to return current. So yeah, we can just do ms is equal to our current window initially. And then for, we'll start off by for I is equal to k, since we already made our current variable with the first k elements. Oops, let me just declare it. And I is less than n, and I plus plus. And we can just, as I told you before, add the next item and subtract the previous last element. So we can just subtract nums of I minus k. And we can just set ms is equal to the maximum of our current and ms. Lastly, you can just convert it to double, which I use static cast. And we can just write here our ms divided by k. And this is our program. Let's try to run it. As you can see, it passes the initial test case successfully. And there we go. It successfully works. So guys, this was it for the part 1 of sliding window. If you want to see about dynamic sliding windows, make sure to subscribe and stay tuned for the next video, as I will explain the fundamentals of dynamic sliding windows. Hope you like this video and see you next time.